Thank you, Colin. That was a very interesting talk. And I agree with Marco that seeing it as a talk definitely went a long way to making it, tying it together a little better than the paper. There's a lot of weeds in the technical details that one can get caught up in. So I thought I'd like to start with a point of clarification, a question about clarification, because I really want to understand what you are aiming for with this flexible production system sort of framework. It seems to me that the flexible production system model is still susceptible to a one-to-one function station mapping. It's just a different level of function that we're thinking about. We're thinking about sort of the operation of a lathe or the action of a drill press, and not some higher level function like making a gear or creating a table leg. So do you see this as, are you trying to take a step towards a clearer or cleaner function ontology and relations between the two sort of parts of our cognitive and brain ontologies? Or do you think there's some ineliminable degeneracy between the brain and our sort of concepts of cognition, and part of what you're calling for here is to preserve that degeneracy?
Oh, it's a good question. I suppose my instinct, and in some of my papers I've kind of toyed with this, and it's gotten stronger over the years, is not the cleaner functional ontology, but actually something like ineliminable degeneracy. But rather than thinking of it as a problem, embracing it and running with it. So I think there's an interesting level of description. As you can tell, I've also become more and more of a computationalist over the years. The interesting level of description is going to be something like an algorithmic level of description. And that's not going to use, or not necessarily going to use, any traditional cognitive terms. So I think there's a demarcation problem here of saying, and I've gotten in fights with people over the years of saying, well, why don't you just call that the cognitive? And sometimes I'm more sympathetic to that than others. But I suppose I do think that it's a good, so in the computational case, it's useful to split up the explanatory burden between, on the one hand, the kind of algorithm and processing level of description, and if you'd like, something that sounds more cognitive and is more closely related to mind. So that may just be saying the same thing again in different words, but let me pause and see if that's helpful.
Yeah, I mean, that seems to make sense. My mind is drawing analogies to Mars 3 levels as you were sort of breaking that down, and that seems to be the kind of a model that you have in mind.
Yeah, and that's where my mind was going as well. I think I've become more sympathetic to Mars over the years. That in some sense, this is going to be very crude, and I'm not sure if I would completely endorse this in the light of day. That I think of cognition essentially as involving much more of the Mars computational level, and then there's this algorithmic level that's really important. And then we've got a lot of stuff about implementation with neurons and things, but trying to sort out that algorithmic level as an intermediate level, I think I feel like is the important task.
Cool. Yeah, that helps a lot for sort of making sense of what the broader project is here.
Yeah.
So
one more thing to say about that, but I'm happy to.
Yeah, please go.
Well, the other reason that I think it's important, and this is, you saw me give a talk on this ages ago in Berlin, and the other thing I think is important about flexible production system stuff is, and where you're starting to get a dissociation with thinking about cognition generally, is I think there are lots of functions that the brain does that are called kind of housekeeping functions or supportive functions or something like that, where and that computational systems have to do as well. So if you're going kind of top down and you're trying to start with human tasks and human capacities, I think you can get interesting breakdowns into kind of information processing and nice box and arrow diagrams. But I also think there's a lot of things, I've been using cognitive control as the blanket term there, that don't fit neatly into that framework, because there's stuff that the implementing system has to do in order to make sure that the information processing proceeds smoothly. And that in certain things like flexible production systems, that may actually be a large part of the work is making sure that you don't have collisions, you don't have, resource starvation, things like that. So that's another reason why I'm interested in maintaining a distinction between the two, because I think there are these other interesting processes that you don't get, at least if you start with a top-down approach to understanding cognitive function.
Yeah, I'm definitely very sympathetic to that view. I've recently been interacting a lot with people who work in looking in sort of, I guess dynamical systems is the right idea, but they're looking at effective connectivity. And one of the interesting things that I've noticed is different about the way they're thinking about the mind, about the brain, is kind of, it's cohesive with what you've just said, because they're really concerned about temporal issues, and in particular, like how different states of the system seem to prepare it for performing certain kinds of functions. And so, and I was thinking of that when I was reading through this paper, and I was imagining a machine shop that's got like obstacles, just sort of, things have to be put places. You don't quite have enough space, and sometimes you have to move the toolboxes, and this sort of kind of like, in any case, I find it fascinating. Every time I read your papers, your analogies end up blossoming in my mind. So I'm not sure how much time I'm supposed to spend chatting with you. Oh, is that clarification?
I guess you can have a brief question now or a longer one later, because we have time. We're not.
We can do another round of questions later.
Sure.
Yeah. So.
In that case, we'll see how brief Colin makes this. But I'm curious to get your thoughts on where to from here, because one of the biggest challenges with data-driven stuff is figuring out what the next steps are. Data-driven techniques are usually put forward as ways to generate hypotheses. And so this seems like a really interesting approach to start getting a grip on what a many-to-many mapping might look like. But I wonder, what's the next step for something like this? How does someone take, say they do this with a richer database like the brain map database, and they come up with these kinds of relations? What kinds of hypotheses should they be looking for to go on and look at more carefully in subsequent work?
Yeah, that's a really good question. I've spent so much time getting this up that I keep forgetting to think about what to do with it, because I still have this philosophical instinct that the answer is to stare very hard at things and then puzzle out what it all means. I'll try to make this quick. I mean, I do think there are probably some things to do. So one interesting start would be to try to look for things that look more modular or one-to-one versus things that are more dispersed. And then, kind of look at, I don't know. I mean, I should say the problem is with data-driven stuff, as I've found working on various things, it's very easy to come up with things to do because it says that, finding principled things to do with it is much harder. So in the background, I always have a kind of interventionist bent where I think my hope is that some of this could then be used to guide, TMS or more direct intervention to see if you can find, what happens if you knock this bit out. Do the consequences tend to align up with how they're weighted, this kind of thing. So it does suggest, I think, interesting experiments you might do. The other thing and I'll say this, you're never going to get a short answer from me, unfortunately. Mark, I should know this. The other thing I think that's really interesting and doesn't get done a lot in this end of science, although there are parts of cognitive psychology that care a lot more about it, it's just as predictions for interference experiments. So trying to figure out which tasks, which tasks will interfere and perhaps unexpectedly diminish performance on others, or which combinations of tasks. And Jonathan Cohen gave a really nice paper at SNAP last summer about this, trying to do it within the cognitive control area. But I think in general, if you've got a kind of reuse thing, and one thing you might be able to get out of this more directly is to think, okay, well, if you've got this, can we make this cognitive performance diminish or break down in certain ways, given what we know that these areas are also involved in? So if it's more, if this is tracking something right, then if it's really involved in this kind of task, then something which also loads heavily on this should be harder to do simultaneously, and so on. So there's kind of more data-driven things now about collisions and that sort of thing.
Colin, thanks for the talk, first of all. I really enjoyed that, and I also enjoyed reading the paper. I was fascinated. I got maybe 20 questions. I'm just trying to think which one to ask first. So let me maybe start with some more technical things. So
Okay.
How, for instance, did you identify the cognitive topics, and what are those, as you called them in the paper, meaningful brain joints that you found so far? Are these I mean, I assume you just mean these voxel hotspots that pop up in your analyses. And I wonder what these regions are. I mean, some of them seem to be like visual vertical area, motor cortex, and yeah, maybe you can just tell us what they are in the slide.
Yeah, so well, I'll try to do it without the slides, and I'll say something more. So the actual, let's start with the kind of voxel hotspots. Those are actually automatically extracted by the NMF algorithm. So what the NMF algorithm is trying to do is to say, okay, find me a set of, so I have to give it a number, 48. Find me a set of essentially 48 parts that give me the best, when weighted, will give me the best approximation to my original data set.
Why 48?
Okay, so that's the good question. This is the, so that's the one I actually used. I should say the algorithm itself in any topic modeling, you can ask it for any number. It's like a clustering, and it will give you that back. So the main challenge in a lot of this is finding a principled way to pick some number rather than some other number. Because, I ran it, it goes by very quickly, but it's the greenish figure 2 in the paper itself. So I ran it for every combination from 6 to 96 for each, both for voxels and for words. So the more technical thing, and this kind of got out of order in the talk, essentially what I did was I went through each of these. There are measures of fit for how well it reconstructs the original one. Those tend not to be very useful. They tend to just increase linearly. So you're always, all things being equal, the more the better. And I should say, when people use this just for document retrieval and just for pragmatic purposes, in general, the answer is as many as you can get in a reasonable period of time, because that gives you better classification. Mm-hmm. What I did, and since that's not what our interest is I generated a series of models both for the word matrix and for the voxel matrix. I then went through, and for each combination of those, did the regression procedure that I described. So I said, okay, give me the many-to-many mapping between this set of voxel topics and this set of word topics. And then that gives you an R-squared, so a measure of goodness of fit. So how well, once you get the weightings, how good is that fit? I then picked one and that's what you're seeing in figure 2. So figure 2 is the R-squared for each combination of voxel topic and word topic. And then essentially look for patterns in there. So the voxel one, 48, seems to be the clearest peak as it goes along. For the word ones, it gets better the more words you have because of the direction it's fitting, the kind of more fine-grained it is, the better. But so essentially 48 seemed like a good one. 36, that's a little bit more arbitrary, but that's where it starts being within 48 better than anywhere else in the matrix. But so once having picked 48, and I should say this is fairly robust on the other ones as well, though, once you get above very small numbers for the voxel ones, it starts giving you these pretty recognizable blobs, along with some of these more interesting, what look like networks. What happens essentially when you start adding more and more of them is you start getting more very non-specific, so very large things that I think are just modulating global signal or something like that, or associated with global signal. But in fact, I wonder if I actually got this up just in case. So it's hard with these because you can't really put everything in. I did intend to send around a matrix, but if you wanna see what this looks like, because there's always this kind of selectivity, just very briefly, I will show it to you again. You see my screen? So this is the kind of raw output for each of the topics. And what you see is, can you see this all right?
Yep.
is this coming through on the screen sharing? Yeah. So
can
you get lots of, sorry?
Can you enlarge the window? It's pretty small.
Sure. And there, is that a little better?
A little better, yeah, cool.
Yeah.
Yeah.
I'm also happy to send this around to anyone as well. So in the extraction, some of these you get very clear hotspots around things like thalamus or early visual cortex. And it's not a huge surprise because these tend to get reported together in papers. The nice thing is it's pulling these things out without necessarily knowing that it ought to be pulling out even parts. And then you start getting down, some of these start to get more networky. There's always one that looks very much like default mode. So some of them you get more non-specific. There's one, 24. So this one only has one, but it seems like sometimes I think it might actually be a white matter one. I'm not sure whether it's white matter or global signal. I was pretty convinced it was white matter. But you go down through, and some of them are messier, and some of them are, you know, you do get ones that are pretty lateralized, and then, yeah, so, you know, you get a lot of these, but they tend to be fairly blobby. I don't think, this doesn't have any threshold on it either. So some of this is how people report things in papers. I mean, so all of this, there's going to be some real complicated interaction with how people talk about stuff. So I just want to, so I didn't have a threshold on this.
Sorry.
Yeah, let me stop that and get back to my face.
All right. You're back.
All right, good.
So the fact, what you just said, that it depends a lot on how people report things. That actually brings me to a related question that I had about which parts of the papers you looked at, because often what you find in empirical papers is that people report like, okay, this region so far has been associated with X, Y, Z, but we are now going to show you it's actually doing that. So then what you would find is in your analysis, well, you know, when you just extract the words and the regions, you would get, say, STG as a primarily auditory area. But then if you look at sign language study, you find that it's actually not just an auditory, but a grammar area. So the argument of the paper would be, well, people think it's an auditory area, but it's actually a grammar area. And then your analysis wouldn't reflect that. It would associate this area with both, like STG would be associated equally, at least, with auditory and grammar.
Yeah. So there are kind of two responses. I mean, both of these are going to be, yes, acknowledging your point, and this is a kind of hard problem. The first quick one that's specific to neurosynth is neurosynth goes for the, like, food can be bad so long as the portions are really big kind of philosophy. So neurosynth doesn't try to solve this problem at all. It's really scraping these studies and ideas. If you get enough of them, hopefully a lot of this will come out in the wash. I mean, it doesn't even try to look at, so it's just reporting the individual, you're taking the foci within tables and not trying to split it up. So if there are two things going on in an experiment, all of the words in the experiment will get associated with both reported sets. So it's messy, and again, the general hope is that stuff will, you know, this will be washed out as noise if you have enough of it. That said, if there are systematic problems within a certain area, that might just be reflected in neurosynth as well. The deeper problem with this, and one I worry about, and Tal at some point convinced me that it was okay, but now I've gone back to worrying about it again, is that there's going to be a bias towards things that are done more often. So if there aren't a lot of sign language studies, now hopefully they will show up. You know, it's surprising, even stuff that I wouldn't think would show up very often, like pulls out, you get surprisingly specific things. But if there just aren't, I mean, in the limit case, if there are no sign language studies, then of course you're not going to get anything talking about, in the database, you're not going to get anything talking about sign language. I feel like this is I mean, maybe a way to turn this into an opportunity. I think, you know, maybe the best thing to say is that the kinds of stuff that Jesse was talking about, another thing that might come out of this is you find stuff and you get kind of hints of what it might be doing. That's a place to actually try to start testing things in different domains or going to different domains that aren't included in here or looking at the studies more carefully. Because there is a general bias. So, I mean, one thing that falls out of this is there's just a ton of reading studies in the database. So there's always a really strong reading topic that falls out. There's also some stuff that just ends up kind of noisy. Like there's always something about Alzheimer's and cognitive decline that I think is just a mess, probably for the reasons you've mentioned, that you get things, it's just all over the map and people are looking at different things. So yeah, I mean, I'd be very careful about, I'd certainly be very careful for anything like this about concluding that something's not involved in a region. Although that's rarely what falls out of this, or sorry, that something's not involved in a cognitive function. But yeah, I mean, I think there's some deep home there, and I think it's so worth it with, in general, with meta-analyses about how to deal with this, you know, this waiting problem of what's been studied and what hasn't been studied.
And also what's been reported and what's not reported, because negative results rarely ever get published.
Yeah, I mean, that is a legitimate worry, although I think my impression is that with fMRI, there's a lot more, you know, you're always getting some blobs, so at least this is a different kind of problem. So you're always getting something that you can put up there, no matter how crappy the study is. So I worry about that slightly less. I mean, the other thing I think, and again, this has been something of a bugbear for me lately, but to get back to something I said to Jesse, the other thing I think that's not done because of the kind of subtractive paradigms that people have in mind is thinking a lot about either that this could potentially at least help with, is thinking about even not like, you know, less frequently studied things, but interactions between frequently studied things. So it's one thing to study reading and another thing to study animal, you know, animal identification or something, but thinking about, sorry, I have a toddler, so I've been reading a lot of books aloud about animals and about this, you know. Obviously there are contexts where both of these happen, and there's a really nice old paper from Friston talking about how basically, you know, you find interaction effects when you go looking for them, and that should be useful, but I think it's still something that people haven't explored as much. So some of this was initially me trying to think about interaction effects, but not sure where to go with it. So that's mostly just to acknowledge that, yeah, it's a problem and to try to say some stuff about it. But
Colin, yeah, thanks so much for the interesting paper as always. I've got kind of like some sets of questions, and I'm going to see if I can summarize them as briefly as possible. The first is about, can you hear me, Colin?
Yeah.
Yeah, okay. So the first is kind of about the machine shop analogy, and kind of multifunctionality. So there's one way of describing multifunctionality, which I think is closer to the Anderson way of doing it, at least in the 2010 BBS paper, where he, and this kind of fits with the lathe thing. So how do you get multifunctionality out of a lathe? Well, you just lathe something else with it. But I think that there's other kinds of multifunctionality. So for instance, I don't know, what's coming to mind is a Dremel tool, where you've got sort of the same basic force at work, but given the trappings, given the attachments on it, you get you know, very different tasks that this can contribute to, where it's not really doing precisely the same thing. It's doing something slightly different or slightly flavored by the application it's being put to. And this connects up to a broader question I have, which you address at the very end of your paper, and that's sort of as a mechanist, sort of down to my socks. I'm worried that you're so even if we get some useful sort of sense-making principles out of this kind of big data approach, we don't really have. It's not just that the question is not answered. It just doesn't really address some of these worries about exactly how multifunctionality works within these systems. So I suspect that you'll have a bunch to say about that, but I kind of wanted, I guess I was putting it rather strongly, and I want to see what you have to say about it.
Yeah. Okay. Good. That's very helpful. Let me take this in reverse order. Yeah. So I think, and maybe this speaks to some of the other questions that are there as well. Because yeah, I mean, I like mechanism. I'm cool with that. I suppose there are two ways to think of what comes out of this, and it's whether you think of it as the explanandum or the explanans. So I think you should think of it as the explanandum. So essentially what this is doing is giving you a bunch of more interesting and sophisticated data that a mechanistic theory ultimately has to fit. Okay. And constrain it, and hopefully trying to constrain a mechanistic theory that way. It's not the mechanistic theory yet, but it's going to give you more interesting stuff than trying to do a one-to-one mapping. I mean, I actually think a one-to-one mapping is not yet a mechanistic explanation anyway. It's easier to translate into it, and so it looks more like a mechanistic explanation. Whereas here, I think, yeah, so what you're going to find is, okay, so here's this interesting pattern. This is how I've been thinking of it. What's going on here such that it's involved in these different things? What's going on here that it's involved much more in this kind of task than that kind of task? I actually think the cognitive end of things, there's a more sophisticated thing that I've never gotten to work, but I think actually carving up the different tasks as well is also an important part for mechanistic explanation as well. So carving up the phenomena in ways, and grouping and separating things that ought to have the same mechanistic explanation or might have different explanations. And so I'm interested in the data-driven stuff, even on the top end, in part for setting the stage for that. So I think that's a really good question. That's something I should emphasize. That yeah, I think that's ultimately the next step is trying to come up with mechanistic theories that would account for the patterns of data you see, and then trying to do experiments to test them. So it's not going to give you the explanation directly. The other thing, and so to go back to the Anderson one, I mean, I do think there's a really interesting problem here. So I like I like being given more tool analogies to my tool analogies, and I like the Dremel one. So this is good. So, and I think this is my impression that Mike has shifted his view from 2010 into later. That it's really, you can't even say much there. I think at the heart of this is a really hard problem that I've thought through enough to describe, but I still don't quite know how to solve, which is that when to say that you have a function that changes as you change something important versus a function that has more free parameters than you initially thought it had. And I suppose kind of formally, there doesn't seem to be that much of a difference between, you can always kind of query a function to make it come out the way you want. So there might be some kind of cool solution there. Otherwise, I feel like it ends up being more of a like an explanatory fruitfulness kind of argument or something like that. But yeah, I mean, I do find it difficult to know how to draw that line there. And there should be clear cases on either side. Because I do think when you've got, for example, cases like reading where you've got pre-existing neural hardware that's getting reused for something else, and also, the Hain-cell stuff, clearly something's being changed as it goes in, how to think about that new function and how to think about the function in different contexts. So I think that's a really interesting problem. Again, like I said, I can only describe it. You and I should talk about it more while you're here, because I'd love to pick your brain more on this when we're both in the same time zone. But
yeah, well, so I guess the place I've come to with it is that these are both aspects of sense making and investigation, and I think. Sorry, this is going to be inside baseball, but I think all the contextualist really needs is just the view that you can't eliminate context from the analysis for both explanatory, pragmatic, and for investigative purposes. That's sort of got to be part of the story. Anyway, I could go on at length about that. Real quick, because I want to leave other people time. I also want to, so bridging off that, come back to the ontology question. So at times I find myself trending in a little bit of an eliminativist way. And there's a couple of reasons you might think that. So this is stemming off of some of what Lana said. I love neuroscientists, but they often don't spend a lot of time, thinking about whether they're using memory in the same way across a lot of different contexts and so forth. Or if they do think about that, then there's a worry about whether the particular distinctions hold up. So I'm thinking about recollection versus familiarity memory. I can't for the life of me convince myself that there's a really deep distinction here, but there's dozens of imaging papers trying to tear apart these two things. Similarly, for instance, neuroscience tend to use the word cognition much more broadly than philosophers are happy to use it. You could multiply examples. So that's one worry about this kind of approach. Another thing that sometimes I'm friendly towards, and this is sort of scarily almost a Utah kind of point, is that one thing we do have better grasp on is what's going on in the task. So why not avoid some of these worries by, rather than going for a cognitive ontology, going for a task ontology, and that might give us a firmer grip on what's going on in some of these cases, given these worries about usage, given the worries about negative results that Lena mentions.
Yeah. I mean, I don't think it's an either-or thing. I do actually think that a task ontology is really sorely needed. I suppose the reasons why you'd also, so there are a few things you might, I like task ontologies. I'm not sure you're actually going to be able to completely draw task ontologies in the absence of also thinking about underlying cognitive stuff.
Yeah.
So that seems to me like a very kind of whimsy place where you're going to be continually you ought to be continually refining both.
Yeah.
And this is something, I mentioned this in papers, but this is something I thought of even from this in the history of neuropsychology as well. Trying to figure out, it's a non-trivial thing trying to figure out, so classic example, what do you have? Do you have a category of face recognition, or do you have sort of overlearned expert recognition with things with very fine distinctions? I mean, you can do it at a task level. You can kind of look for interference and things, but I would despair of trying to do that in a principal way without starting to try to postulate mechanisms in order to separate out cases.
Yeah.
So that's my reluctance about that. I mean, there's another thing which contaminates this a bit, but I'm much more willing to be an eliminativist in a stronger sense about folk psychology. So all of this is, oh no, my computer is, okay. So there's another question here, and I think this kind of gets run together as well. And unfortunately, it's kind of hard with this data set because you get both, like, as you say, people talking about memory, and then in some very broad sense, and then some very specific technical term that's come out of this literature. And it may be that some of the terms like memory just end up falling apart when you push on them too hard, and you really should kind of, they become like jadeite and nephrite, and you really should start separating them. So yeah, I mean, I think that those are cases where it would be interesting. We had Donna Addis, I think she's now writing some interesting stuff on this. We had her for a conference once, and she, I think, as a working scientist who's done a lot of really good stuff on memory, I don't think it was a crisis of faith, but she was just like, wait, there are so many of these different things, and I'm starting to wonder how I I just use the categories everyone, I like that score, that everyone has.
Yeah.
So I think, I think there is interesting work to be done in that as well. But yeah.
Hi, Colin. Thanks a lot for your very nice talk. And I have two questions.
Okay.
One is concerning the flexibility shop you mentioned at the beginning of your talk. Because it seems to me that the advantage of having a straight line of production is that the order or the constraint is much clearer than in the case of the flexibility. For instance, suppose you have to bend a piece of wood, for doing a part of a ship or something. Possibly, if you have to bend and then to cut it, it makes a lot of a difference in the amount of force you have to exert on the piece of wood when you want to bend it. Because if it's longer, obviously you have to push it a little bit less than if it's shorter. So it seems that it's not that you are just free floating the kind of tasks and operation that you have to do on the object, because the way in which you set the operation determines the way in which the constraints are going to change the kind of job you're going to do. So it seems to me that it has really to do with the kind of design, the kind of the project you have in mind, the flexibility. So there is some sort of trade-off between the flexibility and the design. So that's my first question.
Yeah, sure. Or do you want to? Why don't you go ahead and ask both, and then I'll.
Yeah. Basically, it could be related in a way, because I was thinking about the idea of carving the task that you were mentioning right now, because it seems that in some tasks there is a dependency relation. For instance, consider the relation that there is between edge detection and object recognition. It seems that in order to have object recognition, you have to have edge detection, but not the other way around. So having the list of tasks is not enough, because there are tasks that are subtasks of other tasks, and there are dependency relation between them. So in a way that connects, as you can see, to the flexibility issue. So I wonder how you can have these two aspects factorized out from the kind of system you are imagining.
Yeah, good. Thanks. Those are both really good questions. So for the first one, just some clarification. Yeah, I mean, in general, I actually wasn't thinking, this is a good point, I wasn't thinking that kind of any bit can go through in any path. I was actually kind of thinking that by and large, you've defined it, for any particular kind of thing that you're going to build, there is a well-defined pathway through that's going to be optimal. It's just that that's going to differ for different things. So some things need to be cut first, and some things need to be bent first, and so vice versa. Now, it may interact a bit with degeneracy in the sense that there might be like suboptimal things if you're under a load or something, but I wasn't so much thinking about that. So yeah, this is why I have a bit that goes by very quickly in there that I keep meaning to expand, that there's a sense in which for any particular task, especially if you're doing it without distraction, it's just going to look like an assembly line in some sense, because there is going to be an optimal way through, even for the machine shop, that's determined by it. It may have more back and forth and that kind of thing. But so you really only get this when you start looking at, the reuse of the same thing in different environments. As for the second one, I mean, I think absolutely. And so this is something my student, Annalie Johnson, who's now back she's doing a dual degree with Nijmegen, so she's back there, has written some on this. We've talked a bit about it. So I think one of the things, and actually I think this is an area where philosophers can really do a lot of good, is because absolutely, so tasks in general, there are all kinds of hierarchical relationships. And I think people tend not to think about that too much, although there is interesting stuff in the kind of learning complex tasks literature has a lot more about this. But so you get a couple different things. You get hierarchical relationships, so they're all hierarchical. You're going to get composition relationships, so you're going to get necessitation relationships, as you say, so you can't do various kinds of recognition without a more simple one. There's going to be determinable determinate relationships. So, and I think a lot of the debates, this is what I was talking with Dan about, this idea that this question about whether you've got two distinct tasks or whether you've got determinants of the same determinable. So I think there is a lot of really interesting hierarchy possible here that's mostly implicit. I've played around. I think that's also an interesting place to do data-driven stuff. I've tried several ways to do it with the Neurosynth database, and then I think the Neurosynth just doesn't have that. It doesn't have enough information to try to recover that. I'll put it that way. I'm pretty sure now it's Neurosynth's problem and not my problem. But yeah, so I think those kinds of analyses, I mean, they're partly empirical questions, but they're really important, and I think that's really important to think about.
Yeah, if I can say a little bit more, because it seems that in this case, the many relations you were pointing at the beginning of your talk are, so to say, two-dimensional. While if you put inside this also dependency relation, then the many dimension gets into three-dimensional in a way, because they are not just reciprocal constraint, as in, in a simple many, you know, the recipe and the ingredients, but they are now, as we were saying, hierarchical constraint. It is constraint from below that may affect both, you know, the many interaction at the very same level, because the edge detection may interact with, you know, with both object recognition and process recognition or something like that.
Yeah. No, I mean, I think that's quite right. And actually, I have to chew on this a bit because it's something. Sorry, no.
Yeah, sure.
What if I ran this data? But I think that's right, and it's interesting to kind of think about. Again, what kind of hierarchies you might have in there. I mean, one thing that would be really interesting, I realized I haven't. This is what makes me end up staying till 2 in the morning. That I haven't actually done it on the dimensionally reduced stuff, but yeah, so you could start looking for things like asymmetric dependency relationships. So when you have this, you always have this, but not vice versa. Those kinds of relationships, and Annalie's got some of this in her dissertation, seem like at least a first pass to trying to find out some more of these hierarchical relationships.
Yeah.
Thank you, Simone. Well, it's not a real question, but I abuse my power of being an organizer to ask, why don't you, before switching the word to Philip, who also has questions, could you try to do something like that also on brain map database? Would it be useful?
Probably. I don't know what brain map will give you these days. The technique is pretty straightforward, but does brain map let you download the whole? So brain map's up to 3,000 papers, which is. I should look back. I looked at brain map a few years ago, and it was hard to figure out how to use it. On the other hand, I'm much better at doing this stuff now. So it would be interesting to try and to see how much convergence or divergence it is, given that brain map is much more interesting. My impression is that you can't just get the whole pile of stuff. But if anyone's more familiar with brain map, that would be good to know. So the nice thing about Neurosynth is, if you want, you can just download the entire database that's been scraped.
Yeah.
In fact, I think if you want, you can actually download the scraper too and run it to your heart's content on things.
All right. Thanks, Colin. This is really a cool talk. I have 2 questions, one sort of global and one more local. So the global one is what you think about the role of sort of network science and graph theory in understanding what kind of system the brain is. Because I was thinking when you were mentioning sort of the flexible production system about the difference, for instance, between a hub node and a peripheral node. So a hub node might be more like, you know, this station in the workshop where like a lot of different pieces get moved through and perhaps being performed, the same operations being performed in them, but also perhaps different operations. And then these peripheral nodes may be more like modules in that traditional sense. So what I'm sort of guessing is that we might, in the end, if we go to this more graph theoretical approach, find that there's sort of like a continuum of between like more modular assembly line brain structures and more sort of flexible brain structures. And so that would be the first question. The second question is about these housekeeping functions that you mentioned. So that's something that I'm really interested in, and I have.
Yeah, I know.
Sort of, yeah. And,
okay, guys. Yeah.
Yeah. So one thing is like a very general question is like sort of what you think how to investigate them and whether like you see neuroimaging playing a role in that and what role. So for instance, I'm thinking about resting state fMRI where you may pick up like other stuff. For instance, like there's this paper on like the glymphatic system and resting state in the brain that it may pick up some of these fluctuations in like clearing of protein. So that might be one thought, or it could be others. Then the other question, or the other part of that question, is like, what do you think is the relationship between these housekeeping functions and cognitive functions or cognitive ontologies also? Because so one intuition is that all of the brain has to do this kind of housekeeping to sort of maintain itself. So it at one level might not be amenable to sort of decomposition in the same way because there might be less specialization. Then on the other hand, there might be more specialization in these housekeeping functions, for instance, like different metabolic profiles of brain regions. And so then it becomes a question of how to relate these types of metabolic decomposition like cognitive decomposition. So that's like, as you can see, like maybe a bunch of questions I have because I'm really interested in that. But yeah, just what your sort of general take is, or are you more interested in this sort of routing infrastructural stuff?
Yeah, no, there's a lot of good stuff there. I'll say a few things. I know you have a paper on this, right? And I'm trying to find it because it's supposed to be in my pile of stuff to read. But perhaps you could email it to me again because
sure.
I know you've got something on this and I'd like to read more. So a few things on network science. So yeah, on the one hand, I do think it's really interesting. I do think my impression, having looked at this a while back, was you do get a distinction and something of a gradient between more central things and more kind of peripheral, maybe what look like more modular functions. I think when I was originally thinking of this, I think some of this stuff is a question about whether the more hub-like ones ought to be described in cognitive terms, or as I was talking about then, more in terms of the kind of routing kinds of things. So the example I used to use in talks, there's some really nice stuff, at least early on with bilingual, a lot of the bilingual things would show activation in the caudate head. And there was a lot of discussion about, is this a subcortical contribution to language? And there's and I think the thing that came out, there's also a really nice lesion case of someone who had a native bilingual who had damage to the caudate head, who would switch uncontrollably back and forth between the two native languages. So it sort of feels like probably what the caudate does is kind of doing something that eliminates interference between, two well-spoken languages. So I think when I was originally thinking about this stuff, and still to a degree, I think of it, this is bleeding into your second question about as something of a confound, in that if you've got these kinds of routing functions, it's going to be difficult to distinguish them from the kind of heavy lifting ones. Now, I mean, network science, I think there's a lot of good stuff there. I think this is also an area where there's a lot of good big data to be done, and the flip side is that there's a lot of, as I put it, it's very easy to find patterns and hard to know what they mean, which, this is the kind of people who live in glass houses point. So in terms of housekeeping stuff, I will say I may be interested in housekeeping in slightly different sense. So there's a lot of metabolic housekeeping, of course, and a lot of that is really interesting. I was thinking of this in terms of sort of more computationally. So, for example, if I'm running stuff on my computer, and like most people who don't think about computers very much don't realize that there are tons of things going on in the background that an ordinary user is not going to interact with, in some cases can't interact with, but do lots of vital things like maintaining the internet connection or cleaning up old log files or these sorts of things. So they're not housekeeping in the sort of metabolic sense. They're housekeeping in a kind of computational sense, that the implementation itself has a lot of computational demands, which need to be taken care of in a way that may not be transparent from the, again, if you're doing a kind of top-down sort of investigation, because they're involved in so many different things. So it's that kind of housekeeping, and I think obviously you can tell like my fondness for computational analogies here. That kind of thing, which I think stuff like routing and avoiding collisions and so on is going to be the most obvious version. That I think is interesting. So I used to give a talk about this that I'm trying to still finish writing up after all these years, about failures of surjectivity. So this is when people talk about one-to-many and many-to-one mappings, but also failure to be, it's too late to remember logic, a total mapping. This must be a failure to be a total mapping. So that there might be regions of the brain that do things that are essential for cognition that don't show up, aren't really a part in the proper sense of any cognitive function. So that's the sort of, but I think that's probably also a pretty blurry line as well. So it may be that there's more overlap. Other stuff. So sorry, let me pause there.
Yeah. Thanks. Just a very quick comment. I recently found this paper where they speculate about the role of homeostasis in like reducing noise in the system, and so that might be also because that would connect some of this more physiological stuff with this sort of role for keeping information processing running smoothly. So in a system that's in a better like homeostatic set point, then the noise will be lower, and then that increases sort of information processing capacity, or at least like maintains it or something like that.
Yeah, there's some cool stuff, and I met someone else who's working on this. There's some his name I'm blanking on at the moment, but yeah, there's some interesting stuff in the neural homeostasis literature that I don't think has made its way over into any of this other stuff. But I agree. I think if there was stuff like that, it would be really interesting. It might give you kind of interesting explanations of constraints on the system that didn't just posit them as primitives.
Right.
So let me pick the one that I think hasn't yet come up. In the paper, you also mentioned that you talk about the relation between prediction and explanation, and sort of as a broader question regarding like what this research that you did, this corpus research delivers. I wonder, what do you think is what's the major benefit? Do we get explanations, or can we make predictions that we can use for discovery? What's going on there? What do you think is the purpose going to be? Is it more an explanatory tool or more predictive tool, or maybe both? So what's the role?
Yeah, so okay, this is good. And this probably connects up some to what I said to Dan as well. So thinking through this, as big as friends I am with Tal, I do ultimately think explanation is the goal. So I think I think there's a difference between them. I think explanation's the more interesting one. I think just predicting patterns of activation is a good sign that you're on the right track. So again, going back to this, and I think this has been very helpful, thinking that although this is important for explanation, it's not as it were the explanation itself. It's more or less something like hopefully provides a stronger set of constraints on whatever mechanism would ultimately be explanatory. That's the 1 minute answer, but I'm happy to keep. We should talk about this more.
Yeah, we definitely should.
Okay,
cool.
So thank you very much to everybody. Thank you, Colin.
Yeah, thank you guys very much for setting this up. This is fantastic.
Yeah, cool.